regarding the Lean Six Sigma Green Belt project book. As I already announced before, I will not be able to stick to the same hour of my streaming every day because of different circumstances and my other activities and calendar, but I would like to stick to be with you every day. So you can be sure that in the evening, before going to bed, you can always find a new material from our streamings, and this is what actually I would like to keep. So again, my name is Igor Węgowski, and I'm a Master Black Belt in Lean Six Sigma, and I'm engaged in process optimization and improvements for more than 22 years, and from 2007, so definitely more like 12 years already, I conducted trainings and consultancy in Lean Six Sigma, and this streaming sessions is the results of trying to force and offer and give a chance and propose a straight different approach to obtain the knowledge regarding Lean Six Sigma. I mean, why we have to rely on our boss, on our organization, on anyone above us to decide should I know something about Lean Six Sigma or not. Based on, due to the actually relatively high cost of getting this knowledge and getting the certificate, the access to this knowledge is quite limited. And unfortunately, because I believe that we have to learn Lean Six Sigma not to help the company organization to generate some savings and give money to the owners, of course, yes, but not as the first priority. The first priority should be this. We should learn Lean Six Sigma because we can become a better persons after having when we will implement and when we learn about Lean Six Sigma, and from the moment we will apply this methodology on our daily basis, we simply became more useful, a better person. And this is our offer to the companies, to the teams, to my boss, and we can offer it. Doesn't matter where you will for, what industry, what company, what processes, doesn't matter what you will do. Actually, you can benefit from this and use this as your main strength and value for anyone who would like to work with you. And this is why I share my knowledge and experience regarding Lean Six Sigma with everyone. This is why I started the modway, or mod team, mod approach. Mod is from the Polish language Mistrz Osobistej Doskonałości, and it means a master of personal excellence. So MPE, master of personal MOP, MPE. In Polish MOD, in English MPE, but I think I will stick to MOD. So, and what we are going to do, I mean, this is already not the first streaming session. I continue my daily meetings with you. This is not like predefined, prepared, designed a full training sessions. This is more like a discussion. I'm inviting you to join me on perhaps not a big challenging project. I'm not inventing the wheel. There are a lot of this kind of documents on internet, but what I want to do it together with you and invite you to create together. Sorry, not this one. Bloody buttocks. This one, yes. Sorry. So I just want to invite you for sometimes I'm too fast for my PC. I want to do something and PC is too slow and it's not allowing me to really follow my needs. So we are creating the Lean Six Sigma Green Belt project book from scratches together, understanding why each element, each line, each field is needed, what for, and what we have to do. So by the way, I forgot to give here a green color, because everything what is green we have to put. If you would like to follow some very important steps in the book, you have to follow the red elements, like here gauge R&R or preliminary MSA checklist. Yes, so this is point, and I think this is also Y measures. Why we have to Y measures? Why we measure Y's? Why? Okay, great. And I will delete it. Great. So Y measures. Then there is a gate review. Is the project still reasonable and attractive? Yes or no? Then problem from data perspective. Changes in time. Objective, what we have to do, and changes in value objective. So we discussed this last time. And there is also last thing we have to do when we have our data in front of us and we would like to see something else than just the graphs. I mean, don't get me wrong, you have to always create graphs, because the picture or graphic representation will give you much more information than just a number or table or stream of numbers. Because we as a human, we used to analyze pictures. In the pictures we see is going up and down, it's higher, lower. If we apply different colors, it's even better. So in the picture, we used to analyze pictures, and this is why we have to always represent our findings in the graphical way. There's no discussion, okay? But there are still some calculations it's worth applying into the data we collect. And this is why we are coming here for descriptive statistics. And what we will do, I will just show this descriptive statistics here. Come on, let's join these fields. Okay, I will talk about the descriptive statistics here, because this is the place when we collect data about the Y. Okay, so let's think about a little bit about some how we can describe the group of numbers to see something more interesting for us. So what we have the list of numbers, and remember you have to be able and prepared to extend this list and put more numbers. Of course, you should not stick only to this 18. It would make no sense. So more is better. But anyway, it doesn't matter how big your group of data is. You still can apply some descriptive statistics, and few of them are already visible on the graph. For example, what kind of descriptive statistics we can find on the histogram? So we know already this is the histogram, yes, and the histogram is showing what? The minimum and the maximum, yes. So this is the minimum value, this is our maximum value. So what is the minimum and maximum observed in a certain moment of time? So we were collecting these numbers, I don't know, for 1 hour, and now we have the minimum maximum, yes. So definitely we can put here like the minimum and maximum. So we can also calculate the range. Range is the difference between the minimum and maximum. Let's find if Google spreadsheet has a good formulas for that. Functions, statistical. So the average, okay, yes, mean, great. So we would like to have the mean from this list, and this is 24. Okay, now you want to have the max. The max. Oh, this is like when you start typing some equation differently than Excel. In Excel, when you hit enter, you immediately enter everything what is to the left from the cursor, and it's not necessarily be the full function, and then you're lost. Hello, how are you? Okay, are you using the Lean Six Sigma tools on your daily basis? Please say something. How are you? Where are you from? Are you okay? Are you safe? Are you well? Is there anything we can help? So we are just spending the time together. We are just spending the time together by learning some very useful stuff, which is Lean Six Sigma. So you see, the minimum, maximum, and the range is very, very popular. So we can also have an average, which is nothing more than a sum of all the measurements divided by the quantity of these measurements. And I understand that we have here the average, and again we highlight this one. Okay, good. And but you know, the average sometimes may be misleading, especially when the distribution of our data are not symmetrical, are not normally distributed. Sorry. An example of not normally distributed graphs. By the way, here we have some histograms for us to represent certain ideas regarding the histograms, and let's draw some histogram for that purposes. So let's say not normal distribution. I hope it's correctly written. Tools, spell checking, spell check. Good. So I will not here, I will change the colors here because the colors is not important right now. And this is what I don't like actually, because it should be, come on, really. Sometimes I really don't understand all these programmers. They have to learn much more about the user interface. This is what I'm doing right now is totally not in line with Lean Six Sigma approach. I'm wasting so much time. I hate wasting time. Come on, and this is because of, you know what, I'm teaching this. Okay, so I will show you right now the histogram, which is not necessarily normally distributed. I'm not talking even about the time, the shape, but I'm talking about the histogram which is shifted a little bit to the left. Okay, so here we make some white. Here we have some white. Okay, and we have here a little bit longer. Hello, Syed Ali, how are you? I hope you're fine. How you doing, my friend? Welcome. Just leave me a small comment if you enjoy the stream. Okay, so you see, this histogram is not symmetrical, yes? And the problem is, when we, for example, would like to calculate an average value, the average value, the x, okay, let's me perhaps put some more numbers here. Okay, like this. Okay, good. So the average value, what do you think, where it may land? The average may be somewhere here. So this may be an X bar. Please tell me, do you know how to write an X bar? Like insert a symbol, function checkbox, database, function link, checkbox, chart drawings, form. When I would like to do the, not this one, I don't know. I will do this. X bar. X bar, as you know, is the average. X and the bar above the X. So X bar may be like here. But this value, so this, oh, let's do like this. This will be an X bar. Come on. Yes? This may be an X bar and not necessarily will reflect what we can expect from the process in the next turn. The only reason why for learning the historical data is to prevent the future. We have to learn from this. Sorry, I will also unhighlight this because it may confuse you. Okay, so the X bar may be somewhere here, somewhere there, but there is another descriptive statistics will, I think from the process analyze is much more important, is mode. Mode means that the most frequently observed number, and this is 19, not 20, it's 19. By the way, it's, what is the scale here? The scale is strange, doesn't matter. Not 20.1, but 19.9. This is the mode. This is the most important, I think, even more important than the X bar. But definitely we can calculate X bar. It's nothing wrong with that. But you have to understand that if your process is not normally distributed, the average value may mislead you. If you would like to expect the next time the process will run and finish an average value, you may made a misjudgment. Yes, so the average is good, but I suggest to mode commonly occurring value in data set. Great. So this it will be the mode. It's 24. You see, the average is 25, but the most often commonly what was the most commonly occurring value? Okay. There is also another very important descriptive statistics like median. And then we calculate the median. What is median for? The median is is dividing the quantity of our data we analyze into two equally big groups. So to calculate the mediana, we have to sort all the numbers from the minimum to the maximum, and then we divide by 50-50 from the quantity perspective. We are not looking at the value when we divide. When we locate the mediana, we don't look at the values. We just look at the quantities. And then the mediana is exactly the place where we have below the mediana the 50% of the measurements, above another 50. Okay, and this is very important to, for example, draw a box plot. But mediana can show, I'm wondering if we have quartile. And I think we have to identify which quartile, yes or not. Let's see what will be the result of that. Quartile, yes, because we need to identify, I guess, what quartile we need. First quartile. No, and how we can calculate the quartiles. Function quartile parameter 2, value 27 is out of range. Yes, of course, because there is no quartile. So let's again quartile nearest to the specific. Value nearest to the specific quartile of a database. Okay, I understand, but oh yes, and okay, the first data, then a comma, and a quartile number 1. Great. So quartile 1, then we have quartile 2 and 3 as well, because we have only 3 quartiles in a certain group of numbers. Is Bure. How is Bure? Sometimes I'm really lost in few English words. Collection, set, data set. Okay, that's it. Yes, true. So we can have only 2 quartiles in a certain data set. Thank you very much. And this is because you see the quartile number 2 is equal mediana. Exactly. So let's try to see if it will work. So we can do it like this. Here I will just copy the same what do I mean? To copy the same. How can I change this? Is it possible to change this or not? So I want to change this to this. How can I do this? So I have to delete it and then highlight again and enter. Come on, it's so stupid. So please, someone, a good IT entrepreneur, please please code or create something which will take the best practice from the Excel and the best practice from the Google spreadsheet. This I will love. Okay, so here we have 2 and here we have 3. So you see the quartile 2 is equal to mediana. So you know what I will do? I will just draw it in such a way. So mediana is here. I will copy this, okay, and the quartile 1, quartile 2. Okay, let's do like this. I think our histogram is changed. Okay, doesn't matter. So quartile 1, quartile 2, quartile 3, and this is going also here. So we can see the quartile 2 is equal to quartile 3, and mediana is dividing by 50-50 quartile for quarters. Okay, so below quartile 1, so 24 lies 25% of all the dataset. Above quartile 3, so above 27 lies 25% of the dataset. Simple like that. But what actually I would like to also discuss to you is process capabilities, so called the Cp and Cpk 1 and Cpk 2. What are the process capabilities? The process capabilities tell us actually how well we are fitting the tolerance. You see here on this yellow marks marked with blue are all the data that are perfectly fit the customer expectations, so the tolerance. And the process may be all very narrow or very wide. So okay, so we can have a process that is fitting better into the customer expectations, or in words, yes, and to evaluate what is the size, the shape to the tolerance, we calculate a CP, and the easiest you will understand what I mean by CP when I will show you what kind of calculations we have to apply to calculate CP. Yes. Okay. So to calculate CP, we need few elements. First, we need to have a standard distribution. So perhaps I will do like this. I will take this down. I will highlight this. Okay. Sorry. No, I will take this down because the CP will be the result of my calculation. So first I need to find out what is the standard deviation, and the standard deviation of the population of the entire sample text as 0. Okay, good. So we take this one, and we just enter. Pach. Standard deviation is 2. It means currently the standard deviation, the differences, the variation, what we can see, not exactly the variation, is the standard variation. Standard deviation is 2. If I will, for example, put here something like 20, it will definitely increase the standard deviation because suddenly I have 20, so far away from our minimum maximum. Yes, the mode is different. The mediana is different, everything is changing. But actually more 20, everything will change. The quartile is changing because the first one is changing, yes, because I'm putting low numbers. The standard deviation is bigger. I mean, bigger standard deviation, the worse result, worse process is. And what we have to, we are comparing the standard deviation, which is also some equivalent of how my process is narrow or fat, or like thick or fat, yes, because the standard deviation is actually showing us more or less this distance. So if the process is small or like smokwy, sorry, slim, of course, slim. So if our process is slim, of course, the standard deviation is small. If our process is fat, the standard deviation is big. So here, so here we have good processes when the standard deviation is small. Higher standard deviation, the process is more fat. And we are comparing the standard deviation with what? With our tolerance, with the expected value from the customer. Therefore, we talk about the tolerance. By the way, let's quickly check the spell. Descriptive. What the mistake? Descriptive. Okay. Tolerance 1L. Okay, tolerance. And tolerance is nothing else than what? You will subtract from the upper specification, you subtract the lower. It's 4. And the CP you calculate in a very easy way. So you take the tolerance, and you divide by 6 times your standard deviation. Pach. And in our case, CP is 0 to 2. And I'm not surprised because our tolerance is very, very small and the deviation is big. Let's see, what do you think if I will extend the tolerance? So I will make our customer more tolerant. Yes, so for example, he will not accept only between 20 and 26, but let's assume he will accept from 10 to 40. Automatically our CP is going up because the tolerance is much more bigger, our process is the same, and compared to the tolerance, we looks much more better. And this is all about CP. CP has to be always calculated versus tolerance, so versus customer expectations, because CP is comparing the voice of the process. This is the voice of the process, and this is, you know, voice of the customer. And this is the CP. But comparing the voice of the process with the voice of the customer is not always giving you a clear picture, because the process may be very, very slim. I will give you an example. So let's assume, okay, this is a very, very slim process, yes? Yes, I mean, this is the best. And let's assume that the customer has this kind of expectations. So this is the perfect situation. So we are in the middle, we are far away from the tolerance, our process is safe, and we can generate a really good benefits, revenue from this process. But and the CP is very, very high. I may say here is like about 2 or above 2, definitely. So the standard deviation is very small, the tolerance is very small, and look, the CP will not change if the process will look like this. I mean, the situation will look like this. So the standard deviation is still the same, the tolerance is still the same, CP is still above 2, but we are doing a shitty work. Everything what we are producing is out of the specification and it's a scrap. The customer is not willing to pay for this. And this is why we have to focus and look on other characteristics, not only the CP. Therefore, we need a CPK. A CPK actually is doing something like this. Let me try to draw it. So let's assume that we have this situation, okay? So the tolerance is like that. Our process is here, not in the middle. And the CPK actually is doing like this. The CPK is dividing a tolerance into 2 elements, not 2 groups. And we are calculating something like CP and CPK, something like CP, but for these 2 subgroups separately. So now we compare the standard deviation which is within this pile with this element and standard deviation with this element. So first what we have to know, we have to find out what is the mode. The mode, it means the most frequently observed observations. So we have it already. So now what we have to do, we have to calculate this element and this element. And I will draw it and I will highlight it with colors. Exactly the same colors I used there. So first we have to do the okay, left and right. Left side is upper specification limit minus mode. The right is mode minus the lower specification limit. Okay, in this case, really, so let's change something. Let's do this 30. Okay, and now we have different. Now definitely you see, have you seen what I did? I just changed the upper specification limit and I moved the upper specification limit more close to the data. So I moved the upper specification limit, this is the voice of the customer, more to the voice of the process. Okay, now it's 5. So what 5 left is this. Okay, I will mark it exactly as it is on the right side. So this is the pink, no, this is the right, sorry, this is the right, so it has to be opposite, sorry. Good. And this is right. Now it's correct. So the left, you see, this is this one. And this is right. Good. And this is why we have to calculate also left and right CPK. And this is CPK1 will be left, CPK2 will be right. And what we have to do, we have to compare these numbers with the standard deviation, but to be in line with the idea of CP, the process capabilities, we are comparing this with the half of the standard, half of the half of the number we were comparing during the CP. So here we were comparing this with the 6 times standard deviation. We are comparing now with 3 times standard deviation. So it means that left divided by 3 times standard deviation, pach, and again this compare with 3 times standard deviation, pach. And we are using, so this will be a CP, let's move it here, and here will be CPK, and CPK is taking the minimum value out of this two. Oh, sorry. So we are always taking the minimum value out of this because the minimum value means that the risk is on our Lean Six Sigma Green Belt project book. Also a part when we calculate some descriptive statistics, we have some an average, and what is really important for us is to have these two numbers, and these two numbers I will mark yellow because this is calculated. Okay, we mark it as yellow, and this is our starting base. Every Lean Six Sigma project, if you would like to summarize the goal of Lean Six Sigma project in respect to the CP/CPK, is actually about how to increase a CP/CPK. Every time you will increase CP/CPK, you manage to improve the process, you are more stable, less defects, less costs and better quality, and everyone is happy. Okay, so thank you very much. If you like this, please leave the comment. We will continue tomorrow with the measure phase. We look at the process, we look how the process is constructed, and then we will conclude a measure phase and we will move to analyze phase. So thank you very much for being with me. If you really like, say it so, leave a comment, subscribe, share, and okay, so see you next time.